Hi class, this is Neil, and for this portion of the Lesson 9 video, I'm going to point you to where you can look back at some notes to answer some of the questions you've been assigned for your homework and classwork for today. And also we'll review the homework questions that you turned in a few days ago prior to this weekend. So if we look at question 1, which is a question you're assigned to do for homework. One thing I'll point you towards is that the notes that you should look back at are from Unit 8, Lesson 5. If you don't have your notes with you, I'll point you to where you can find those on the Google Classroom. But I'll just make a note here. This is from Unit 8, really Lesson 5. So in the Google Classroom, prior to this week, all the assignments have an answer key that's been posted with them. So for Unit 8, if I go to Lesson 5, if you want to look at the answer key, if you don't have your work with you, we reviewed how to solve exponential or logarithmic functions on really page 2 of the assignment, and that's where those practice problems are listed. Now, a lot of them say refer to the slides, and you could certainly do that. Really, page 3 has a lot that would be helpful for you. You can also refer to the slides. So the slideshow is also attached as a PDF. And when we're solving logarithmic equations, that really happens starting on slide 9, where we review not only how do we solve them, but also how do you input it into a graphing calculator. All right, so that is what you would need to refer to in order to answer question 1 of the review. So for question 2, this really goes back to Unit 8, Lesson 6. So these are questions where we're asked to look at and determine, are these exponential growth or decay? You would just indicate whether it's growth or decay by writing growth or decay underneath the question. So underneath the option, rather. So if you wanted to determine this, let's say you weren't sure just by looking at the equation itself, let's take that 7 times 0.998 raised to the negative t. If I go to Desmos, I can actually just input that equation. So why don't we try it? So that's y equals 7 times 0.98, close the parentheses, raised to the power of, that a with a little b next to it gets me up there, and I'll write there negative x. All right, so if I zoom out and look at my graph, it's a graph that is going up. All right, so that would be exponential growth. So what I'd like you to do is determine which of the remaining equations are exponential growth and decay. And again, I would just use Desmos to look at the graph itself. Okay, so for question 3, you can also refer to Unit 8, Lesson 6, specifically the slideshow. And in the slideshow, the model responses. There's a question exactly like this. Again, what I would probably recommend on a question like this is taking a look at the graph, or another thing we can look at is the exponent here positive or negative? If the exponent is negative, we end up with decay. This is just when we have a base of e. If the exponent is positive, then we're dealing there with growth. Okay, so again, I would, if I were you, go into Desmos and look at that graph. Now, one thing to be careful of there, if I go into Desmos and I type in that equation as it's given to me, all right, so y equals 1500. Again, to write e, I'm going to actually have to type the letter. Let's go back to my numbers. Now, I can go up into the exponent. I just need to make sure that I write exactly what I see. So it's 3 times the natural log. Again, I'll have to type that out. Of 1/5. So I'll just do 1 divided by 5. Oops, so that kind of didn't go in right. So one thing to be careful of there is let's put the natural log, what we're finding the natural log of in parentheses, 1 divided by 5. And then we'll go over, we'll close the parentheses, close them again. And now all that is being multiplied by x. And then we're dividing really that whole thing by negative 1000. All right, so if I look at my graph right now, I don't see anything. So what you might have to do is zoom out, and then you'll see the type of graph that equation makes. So one thing I'm looking for in question 3 is that you've looked at the model responses and your answer is in line with what's in those model responses. Okay, question 4 you do not have to do because we're going to demo that. Question 5 is one that you will have to do, and you'll have to look at the graph in order to answer that question. All right, so question 4, which statement about the graph of f of x equals log base 3 of x is true? All right, so we're actually going to take a look at the graph of this equation. All right, so I'm going to go into Desmos. And actually in Desmos, it's pretty easy to write in this type of log. So I'm going to write y equals, I'm going to type out log, oops. Okay, so now to make that little base of 2, there's next to the 1, 2, 3, there's a key that says a little b. If I press that, that's going to take me kind of down below the log. I'll go back into my numbers, type 2, and then I'll just put my variable of x. Okay, we'll need to kind of zoom in to see that graph. Zoom kind of way in. Okay, so I'm just going to read off the 4 choices and we'll talk about them. All right, we're looking for the one that is true. So first one says the graph has no x-intercept. Well, if I look at the graph of that function, it crosses the x-axis at about x equals 1. Not about x equals 1, really where x equals 1. So it's not true that there's not an x-intercept. There is one at 1, 0. So the next option is the asymptote has the equation x equals 0. So what that basically means is that there's an imaginary line at x equals 0, and x equals 0 is the same as the y-axis, that the graph never crosses. So if you notice, that graph goes off to the right as x gets bigger, but it never goes into negative territory. So that means that that is true. The asymptote has the equation x equals 0. So option 2 is the correct answer. Option 3 is not correct because if I look at the x values of the function never go negative. I could also pull up the table for that function, and we would see that anything below 0, including 0, is undefined. So there's no negative x values where the function is defined. The final option is the range is the set of only negative integers. I can look even at x equals 2. There's a positive y value. So the function does continue to increase into positive numbers. Okay, so the correct option for question 4 is 2. And again, if we wanted to maybe sketch what that graph looked like, it looks something like this. Didn't go quite so high up, but if we make our scale a little large, that is more or less what that equation looks like. All right, so question 5, you're going to need to look at this particular graph on Desmos and see which of these 4 statements is true. Okay, so that's going to conclude this video.